All right, now on to naming and formula writing. I'm going to use as my big example here one of the later ones. This is problem 2-105. And it's one of those that kind of has the big table, and it asks you to do essentially all of the naming and formula writing skills. Sometimes they give you the ion formulas, sometimes the name, sometimes the formula of the compound, and ask you to fill in all the others. And so that's the one we're going to do. Formula writing is one of those areas in Chapter 2 where some students will just pick that up right away or had good experience with it sometime in their past. Others are going to struggle mightily. This is one of those topics that just seems to be, one of those that folks, either, get really comfortable with quite quickly or struggle with and get okay with it, but they're never going to, write odes to the wonders of formula writing. It's an important topic because, as we've talked about in this chapter, there may be 100 or so elements on the periodic table, and they're all wonderful, but the real punch of chemistry is all the crap you can make from all those different elements and how many different kinds of things there are. And we could give them all random names, but we do have to have a systematic way of naming them, and that's what gets introduced here. And so we were talking about ionic compounds in this particular question, and this is the most common one we run across here in the chapter. Remember, the ionic compounds, an element, a metal from the left side of the periodic table combining with stuff generally from the right side of the periodic tables. Metals and nonmetals forming ionic compounds. Ions, atoms or molecules that have gained or lost one or more electrons. In other words, they've got a charge on them. Okay? So, running through here, I'm going to kind of take each one of the entries in the table separately and just go through the process for coming up with either the name, the formula, or what the ions are. So looking at the table here, this is what they want. This is the kind of the headings on the table. They have the word cation, which is positive ion, anion, the negative ion, and then formula and name. Okay? And in this table, they're going to give us, either these or just that or just this, and expect us to fill in all the others. And so that's what we're going to do. Here we go. Taking the first one. Lithium oxide. That's what they fill in over here. Okay. Lithium oxide. Now, a couple of things right off the bat. Lithium, element in column 1 of the periodic table. Certainly on the left side of the table, it is most definitely a metal. Oxide, oh, there's that IDE ending. An element, okay, element as an ion, okay? Not oxygen, atom, oxide, ion. Not fluorine, atom, fluoride, ion. This IDE is kind of the ending we use to say this element, like sulfur, has become an ion, so we call it sulfide. We don't change the name of the positive ions. I don't know why. We just don't. We change the names of the negative ions, of the anions. Okay? And this is oxygen. Oxygen sits in column 6 of the periodic table, and one characteristic of all of the ions from column 6, they tend to form, or the elements of column 6 tend to form ions with a -2 charge. And so when I say oxide, I am almost certainly saying -2. When I say lithium in an ionic compound, there is its formula, Li, the symbol from the periodic table. Column 1 element, all column 1 elements form a positive charge, +1, written in like this. And in fact, the plus, you can write in the +1. Very often you just see the plus sign. So there's our cation and our anion just pulled out of the formula. And then they're pulled out of the name. And in writing the formula, you just have to have the charges add up to, to be balanced, to add up to 0. You can go through the long explanation of, well, we have 2 negatives and 1 positive, therefore we need 2 positives, and derive the formula that way. And there's a lot of good logic in there. But to be honest with you, until you get kind of more used to doing that, The quick way of doing it is simply what's called the crossover trick. Take the number, put it down there, take this number, put it down there, change its sign, Li2O. Okay? Now, don't anybody write a -2 down here as the subscript, as a number of atoms. That's just moronic. You know, people at Georgia Southern don't do it that way. It's Li2O. Other universities maybe, but certainly not here. And so there is the entry for the first row of this particular question. The second row of this table, this time they give us two of these. They tell us Fe plus 2 and PO4 minus 3. Now, Fe, a symbol for iron. So the name is going to be iron something or other. Okay, but I'm going to put that in there, so I know that one already. This dude, a molecule, 4 oxygens and a phosphorus with a -3 charge. A molecule that has gained 3 extra electrons. Now here, this is one of those that you really just kind of have to accumulate the database for. Okay, there are a relatively small number of ions that I ask students in my class to know about. This is one of them. Phosphate it is called. Okay, and so when you hear the word phosphate, you should go, oh, phosphate, PO4 minus 3. Or PO4 minus 3 means phosphate. Okay, you just have to get those two linked together in your brain cells. Okay, and there's a relatively small number of these that I want people to be aware of. This is one of them, so I write the word phosphate over here. Now, this one has the another little naming wrinkle. And remember, there's a distinction we make between the elements on the far left side of the periodic table in column 1 or 2, or over here sometimes in column 3, and this big middle section of the periodic table. Oh my, the transition metals. Yes, iron is from the center part of the periodic table. It's a transition metal that often means its name can change depending upon the charge. There are lots of ways that we've come up with to take care of this. The most common way these days, and the way our textbook talks about it, is the classic Roman numeral. In other words, iron can appear to us in a number of different charges, +1 sometimes, +2, +3, very common, and even higher than that on occasion. I have to tell you not just iron phosphate, because that could mean a number of different compounds. I have to tell you, because it's a transition metal, which charge I'm talking about. This is iron +2, so I write the Roman numeral +2 in. I did not do that with lithium oxide. Technically, I could have written lithium Roman numeral 1 oxide in the previous one, but lithium is not a transition element. It sits in column 1. It's always +1. That never changes. Okay, so there's no reason to specify the charge. Transition metals can change, so you need to specify the charge on those things. That's why the Roman numeral appears. And then the formula writing business. All the charges have to add up and balance and all that good stuff. To be honest, crossover trick. Iron, 3, phosphate. And I need 2 of them. And yes, I know the temptation is to write that. I have just said it's 1 phosphorus and 42 oxygens. Oh, no. I need 2 of the beasts known as phosphate, PO4. When you have the polyatomic ion and you want to indicate more than one of them, put the formula in parentheses. So there is the formula of iron 2 phosphate. Next up, they give us the formula this time. They tell us Al2SO4, put a big set of parentheses, and a 3, and asked us to work with that. Okay, well, here we go. First, looking at this one, aluminum, not a transition metal. Yay, we don't have any of that confusion about the charge. It's a member of column 3 of the periodic table, and those beasts are going to tend to form +3 charges. And its name is aluminum. Aluminum. There we go. Then there's this thing. Now, people are going to try to call it sulfide oxide. If you do that, you're wrong. Okay? That's not what it is. Fill in your database again. SO4, right off the bat. You see that combination, and your brain needs to go, SO4, sulfate, -2. That's what it needs to do. Okay, that is a sulfate ion. Okay, Sulfate, right? And SO4 minus 2. That is the formula for sulfate. PO4 minus 3, phosphate, SO4 minus 2, sulfate. Those you just got to make a part of your soul. And so there's this entry filled out. When you first look at this, you think, oh, I'm done to the table. How about that? I only have 3 entries. And then you look at the next column on the other part of the page, the way it's arranged, at least in my edition of the textbook, and you go, oh, the table goes on. And it does. And so here comes the next one. The next one, they give us the name again. They say copper. They put a Roman numeral, and they put a 2 in there. And then they say nitrate. Okay. Oh, here we go. Roman numeral. We are dealing with dun, 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 transition metal. And sure enough, copper does come from the center section of the periodic table. It is Cu, okay? And now, what charge do we put on it? Remember, transition metals, the charge can vary sometimes. That's why we have to tell you. And we've told you. +2. Nitrate, database. Phosphate, PO4, minus 3. Sulfate, SO4, minus 2. Nitrate, NO3 minus. Okay, that's part of the database here. And then the formula, crossover, copper, 1 of those. Nitrate, 2 of those. And, at a lesser university, they just put the 2 in. But at Georgia Southern, of course, we put in the whole parentheses. There it is, copper 2 nitrate. Next, they give us a couple of ions. Cr plus 3, iodide minus. All right, we orient ourselves on the periodic table. We find this thing. That's chromium. Transition metal. Oh, man. Chromium. Transition metal. Roman numeral 3. This thing. An element that is formed in an ion. Not one of the polyatomics. An element that is formed in ion. I is iodine, so the element negative ion is iodide. Okay? Iodide. Chromium 3 iodide. Formula. Cr1 iodide 3. Oh, there it is. Beautiful. This time, we're given a formula. ClO2. Now, this ion is not one of the more common ones here, but the text does give its name and formula. This is the chlorite ion here. And so I'm going to go ahead and just identify that. It's CHLORITE. Okay, polyatomic ion, ClO2 minus. So, phosphate, PO4 minus 3, sulfate, SO4 minus 2, nitrate, NO3 minus, chlorite, ClO2 minus. Then we got this beast here. Now, Mn. This one is a common one to get screwed up. This is manganese, not magnesium. Okay, so be a little bit careful. They have similar names. This is manganese. Manganese, it is a transition metal. Therefore, manganese. And we're going to have to put the Roman numeral in. Question is, what Roman numeral? MnClO2. Now, the chlorite has the -1 charge. The formula is given to us this way. Just 1 chlorite. In fact, you could write it this way if you wanted to. Ones are typically not written, but writing it out in complete form, 1 manganese, 1 chlorite, that's got to be +1. Okay, just reversing the crossover trick. 1, 1. Okay, manganese 1 chlorite. And there we have that formula. The next one, they give us a name, ammonium carbonate. Now, I should send you off on a wild goose chase to find ammonium on the periodic table. It's not there. Remember, these two are both polyatomic ions. Most of the polyatomic ions are negatively charged. Carbonate's one of them. Phosphate, PO4 3, sulfate, SO4 2, nitrate, NO3 minus, chlorite, ClO2 minus, carbonate, CO3 minus 2. Okay, that's part of your database. Most of them are negatively charged. There's only one common positively charged molecule that has lost an electron. It is the ammonium ion. It has the formula NH4+. Okay, one of the only polyatomic ions with a positive charge. And then, writing in the formula, we do have to do the crossover trick again. One carbonate, but two ammoniums. If I need two ammoniums, polyatomic, parentheses, 2 CO3. And there is my ammonium carbonate. Whew, man. One more to go. This one, zinc perchlorate. They write in the name again. Zinc perchlorate. All right. Now, zinc. That is an element. We write in its symbol over here. We're going to put the charge in a moment. Perchlorate. Yep, another one of the polyatomics. Consulting the database. This one is ClO4 minus. Okay. Now, looking at the formula here, this one is, I kind of wish the textbook were a little more consistent about it here. Technically, I would have preferred it if they had written zinc 2 perchlorate. Okay, in that zinc is at the end, but it is in the transition metal series, and we tried usually to use Roman numerals for them. They didn't in this case, but it is +2. Mainly what they're revealing here is that zinc is in the transition metals, but it is almost unheard of for it to be in any other charge but +2. And so they're kind of expecting you to just kind of know that. And so there it is. I've told you about it. But I would, at the beginning, at least in the Gen Chem text, I wish they'd be a little more consistent and say, hey, that's a transition metal. It ought to have a Roman numeral in there, even if zinc is always going to have Roman numeral 2. Okay, that's just one of those little bits of lore that you just kind of pick up over time. So there it is. That's why it's not written in. Okay, and I'll go ahead and take it back out because this is what the textbook kind of presents us. But it is making the assumption you know or have been told in the past that zinc, even though it's a transition metal, is always +2. Once you have that, then the formula itself is actually pretty simple. Zinc perchlorate, crossover trick, I'm going to need 2 of those. And there is the entire formula filled out, or entire table, excuse me, filled out completely, where you write them from the charges on the ions, or from the entire formula, or from the name, okay? Given any one of these bits of information, yes, you do need to be able to crank out the other 2 pretty readily. It requires you to know a little bit about, from the periodic table, column 1 +1, column 2 +2, column 7 -1, column 6 -2, that type of basic information for elements. For the transition metals, the modification of the Roman numerals that has to be gleaned from the formula or directly from the information given. And then the database of information on polyatomic ions in particular, phosphate, PO4 3, sulfate, SO4 2, nitrate, NO3 minus, perchlorate, ClO4 minus, carbonate, CO3 2, that kind of thing. If you know that information, and yes, there are hundreds of ions known, but this is why I ask you to confine yourselves to, this table, found in the text and the ones in bold. Given that information, you can do an awful lot of naming and formula writing and get pretty good at it pretty quickly. So go forth, practice some of this stuff, and commit these to your database. See you later.